Have you ever wondered how programmers write and debug their code? It's a process that involves not only creating, but also refining and testing code to ensure its optimal performance. Today we're exploring the world of program writing and debugging, which is an essential part of software development. We'll delve into the importance of understanding specifications before writing any code and breaking down problems into manageable tasks. We'll talk about the use of pseudocode for planning, the importance of following coding standards, and how version control systems like Git can be invaluable tools. We'll also dive into the realm of debugging, from understanding the bug through error messages and using inbuilt tools in IDEs, to the simple yet effective technique of print debugging. So, are you ready to dive into the fascinating world of code creation and bug hunting? Let's get started. Before a single line of code is written, there's some groundwork to be done. Imagine you're an architect. You wouldn't start building a house without first understanding the needs of the person who's going to live in it, would you? The same principle applies to software development. Before you start coding, it's absolutely essential to thoroughly understand the requirements and specifications of the software you're developing. This might involve asking a lot of questions, digging into details, and even challenging assumptions. The goal is to ensure that you're not just building a solution, but the right solution. The one that meets the needs of the user and aligns with the overall goals of the project. Once you have a clear idea of what you're building, it's time to break down the problem. This is a bit like creating a blueprint for that house we mentioned earlier. You wouldn't try to build the entire thing in one go. Instead, you'd break the project down into smaller, more manageable tasks. Maybe you start with the foundation, then move on to the walls, then the roof. In software development, we do the same thing. We divide the problem into smaller tasks or modules. This not only makes the problem more manageable, but it also allows us to focus on one aspect at a time, reducing the chance of errors and improving the quality of our code. Breaking down a problem isn't always easy. It requires a solid understanding of the problem, a good dose of creativity, and a lot of practice. But the effort is worth it. By breaking down the problem, we can tackle complex tasks more efficiently, and it's easier to see how different parts of the solution fit together. It also makes the development process more flexible, as tasks can be assigned to different team members or even worked on concurrently. So, before you dive into coding, take the time to understand the requirements and break down the problem. These steps might not involve writing any actual code, but they're a crucial part of the development process. They lay the foundation for a targeted and effective solution. With a clear understanding of the problem, you're set to start planning your code. Planning your code and maintaining consistency are key success factors in programming. Let's dive into pseudocode first. Pseudocode is like a rough draft for your program. It's an outline of the logic and structure you plan to implement, written in a simplified, language-agnostic format. It's like a roadmap for your code, helping you visualize the flow of your program before you dive into the specifics of syntax and logic. Next, let's talk about coding standards. These are rules and guidelines that govern how your code should be written and organized. Coding standards are like the grammar of a programming language. They ensure that your code is readable, maintainable, and understandable, not just to you, but to other developers as well. This includes things like consistent indentation, meaningful variable names, and proper use of comments. Just as you wouldn't write a novel without proper grammar, you shouldn't write code without following coding standards. Finally, we have version control. Think of version control as a time machine for your code. It keeps track of all changes made to your code over time, allowing you to go back to any previous version whenever needed. This is especially useful when working as part of a team, as it allows multiple developers to work on the same code base without stepping on each other's toes. Git is a popular version control system you might have heard of, but these tools and practices aren't just about making your code look pretty. They're about making your code work effectively in the long run. Pseudocode helps you plan your code and avoid logical errors. Coding standards ensure your code is clean, readable, and maintainable. And version control keeps your code safe, trackable, and collaborative. Remember, coding is a craft, and like any craft, it requires planning and precision. Pseudocode, coding standards, and version control are just some of the tools in your toolkit to help you master this craft. Now that we have a plan and system in place, let's move on to the actual coding. Writing the code is not just about making it work, it's also about making it understandable. In software development, modularization and commenting are two key practices to make your code more readable and manageable. Let's start with modularization. It's the process of breaking your code into smaller independent sections or modules. Each module performs a specific task and can be used in various parts of your program. This not only promotes code reuse but also simplifies debugging. If an error crops up, you know exactly where to look. Now, on to commenting. Comments are like breadcrumbs left behind for anyone who might need to understand or modify your code in the future, which might well be you. They explain the purpose of code sections, complex logic, and important decisions you've made. They're your code story, told in your own words. Remember, a well-structured and well-commented code is a joy to work with and can save hours of debugging. With our code written and well-documented, it's time to hunt down those bugs. Bugs in your code? Don't panic. Debugging is an art that can be mastered. It's all about understanding the bug and knowing how to use the right debugging tools. So let's dive in. First and foremost, we need to understand the bug. This involves analyzing error messages and the symptoms of the bug. An error message is more than just a red flag. It's a clue pointing towards a potential issue. Reading and understanding these error messages can provide valuable insights into the problem at hand. Once we've got a handle on the error messages, it's time to reproduce the issue. Reproducing the bug is like retracing our steps to find a lost item. It helps us identify the exact conditions under which the bug occurs. Remember, every detail counts. The more accurately we can recreate the bug, the better we'll understand its root cause. Now that we've understood the bug and its conditions, it's time to bring out the big guns, our debugging tools. Integrated development environments, or IDEs, often come equipped with powerful debugging tools. These can be our best allies in the bug squashing process. One of the most common debugging tools is the debugger, which lets us pause our code at specific points, inspect variables, and step through the code one line at a time. This can help us see exactly where and when things go awry. Another tool in our arsenal is the console, where we can print out variable values or messages at strategic points in our code. This technique, known as print debugging, is a simple yet effective way to keep tabs on what's happening in our code. But here's the thing, bugs can be tricky. They can hide in the most unexpected places, and sometimes our standard debugging tools might not be enough to catch them. But don't worry, there are other techniques we can use. But what if our debugging tools aren't enough? Let's explore some other techniques. Sometimes solving a bug requires thinking outside the box and learning from our mistakes. It's not always about diving into the code, but rather employing a variety of techniques to unravel the mystery of the bug. One such technique is print debugging. This involves strategically placing print statements in the code to output variable values or messages at key points. It's like leaving a breadcrumb trail in a maze. Each print statement provides clues to trace the path of execution and pinpoint where things go awry. Then there's the rubber duck debugging. This peculiar name comes from a practice where programmers explain their code to an inanimate object, like a rubber duck. As they articulate the problem, they often stumble upon the solution. It's a testament to the power of verbalizing thoughts, a technique that can shine light on the less obvious aspects of the problem. Another crucial part of debugging is checking assumptions. Every line of code we write is based upon certain assumptions. But what if these assumptions are incorrect? Going back and validating these assumptions can often lead us right to the bug's doorstep. Once the bug is resolved, it's important not to rush to the next task. Take a moment to learn from the mistake. What led to the bug? How was it resolved? What can be done to avoid such issues in the future? These reflections are stepping stones towards becoming a better programmer. Also, don't forget to document the fixes. Write down the bug, how to reproduce it, and how it was fixed. This not only helps future developers but also serves as a reference when similar issues arise. Finally, the key to being an effective and efficient programmer is the pursuit of continuous improvement. Every bug resolved, every mistake made, and every lesson learned is an opportunity to improve. It's about cultivating a mindset of growth and learning, of embracing challenges, and seeing them as opportunities to enhance your programming skills. And that, friends, is how programmers write and debug their code. Remember, every bug is a lesson, every fix, a victory.